Okay, root test, the same idea, but with nth root. In root test, we write like that. We have nth root of an instead of an plus 1 over an. We have limit of nth root of an is equal to rho. Again, rho have the three cases, the same as the root test, ratio test, sorry. So rho greater than 1 diverge, rho less than 1 converge, rho equal to 1 is not inconclusive. We cannot say anything. We should use another one. I'm going to skip this example first, then later come back to that one, okay? I'm going to skip that one. So I'm going to, here's the rule, here's the theorem, here's the same nth root, not square root, nth, okay? Then proof as usual is not include. And here we are. We have example 3, which is in the previous one. I see I'm going to skip. Later, I'm going back to that one. So we are going directly to example number 4. So how we solve that one is easy. Now you know how it's easy. We have n squared over 2 to power n. That one is geometric series, but with n squared is not. Are you sure? No, shame. Suppose y. Thank you. So as we mentioned, we have a root test. We are going to take nth root. We have 3 cases as the previous one. And here's the first example that I'm going to talk about. So how we solve that one? We are going to nth root. You know, in the 10.1, we have theorem, I don't know which theorem, and we have 6 rules. Do you remember that? So now we are going to use it here. I told you there. Maybe one day later we need in the root or ratio test. So here we are using that one. So I say by root test. So I'm going to take a limit of an nth, which is equal to limit of nth root of n squared over 2 to power n. Nth root, which is equal to nth root of here and nth root of here. And you know that one will cancel. And that one equal to what? 1 squared. How? Because we know nth root of n equal to 1. It was the second theorem in that one. I don't know, in 10 points. Go back to 10. 10.1. We go to 10.2. It's clear, more easier to get the theorem. Here we are. Theorem number 5. The second. You got it. Now you know how much that one are important for you. Good. Again, the example. Yes. Okay. So we got what? 1 over 2. 1 over 2 is what? Our rho. So rho equal to 1 over less than 1. Converge or diverge? Converge. Another example. 2n n to power 3. 2n n to power 3. Yes. Again, by root test, right? So I'll get what? Limit of nth root that I have. Easy. Equal to 2n and n. And the up equal to what? Yalla, numerator equal to what? To that one, 1 to 1 cube. So I'll get 2 rho greater than 1. Easier, right? How about the third example? Yalla. 1 over 1 plus n. All of them to power n. I told you there. In the root test, we have an nth root. Careful. 2 to power n, n to power. So by again root test, I'll get what? Limit of n approach to infinity, okay? Nth root of nth root of what? And I know it remains was equal to so equal to 0. Understood? Easier. So here's these three, they are very important, and look at them. Converge, diverge, converge, because. Okay, last example. You are happy, right? I can feel it. So we have this example. Before that test, he gave you many ideas about that one. He told you if we have such example like that, the term will be like that. The terms, no, it's like that. Look, we have what? N over 2 when n is odd, means that 1, 3, 5. You know about odd. Odd means that 1, 3, 5, 7, and go on. Even 2, 4, 6, and go on. So when is n1, I'll get 1 over 2 to power n, right? When it's n2, I'll get 1 over 2 to power 2. n3 again. So this term is for the odd. And that term for the even. And go on. So I cannot decide. I cannot say even it's a geometry series. Why? Because you are right. The denominator is geometry. But numerator is something else. 1, 1, 3, 1, 5, 1, 7 is not geometry. So he said that is not geometry. And you cannot solve that one by telescoping, you know. And it's not entity. Why? Because I use entity, I'll get what? Infinite over infinite. And I'll get 0. Again here, if I get 1 over infinite, I'll get 0. So it's not also by entity. I cannot say anything. Entity. Okay. So also if I took up absolute value, there is no way to escape. Why? Because this one is not negative. If I get absolute value of here, I get absolute value of here, absolute value. All terms are positive. So I get the same series. The same. So again, is not work. So it's not absolute converse. Now I'm going to what? To ratio test. So if I use the ratio test, I'll get what? 1 over 2n, n plus over. Why? N plus 1 over 2n plus 1. So I'll get 1 over 2n. And how about that one? I'll get 1 over 2 plus 1, 2 plus 1. I'll get 2n. So in both cases, both of them, and I cannot decide anything about that one. Why? Because again, if I use entity, I'll get 0. And the row, I cannot clarify that row is equal to what. So that's why ratio is not working. But I know I have power. Look, I have power. X to power something, n to power something. So first of all, or the other things that I'm going to think about it is what? Is nth root, right? Nth root of here. So nth root of here is equal to nth root of here, nth root of here. Am I right? And I'll get what? 1 over 2, and I'll get what? 1 over 2 again. Understood? So after taking the nth root, look, taking the nth root of here and here, I got 1 over 2, 1 over 2. I know that one equal to what? N to n. Nth root is equal to nn to nn. That one equal to 1 over 2. The same thing is true for what? For the other one, I'll get 1 over 2. So I'm going to use what? I say that series between here and there. If I have odd, I will get that one. If I have even, I'll get that one. Like a sandwich theorem. So the limit of here equal to 1 over 2. the limit of here equal to, again, 1 over 2. So that limit equal to 1 over 2, and it's my row less than 1 converge. So we solve like, and limit is less than 1, converge absolutely by root test. You got it or not? Maybe you got something, maybe. So the difference, that example with the previous one, is we have n odd and n even. Here we have another function, and there we have another function. Okay? And we are going to use nth root of nth root of nth root. I know in both cases I'll get 1 over 2, and here I'll get 1 over 2. So I can see the nth root of an that I have here is equal to 1 over 2, row less than 1, and converge. You got it? Briefly. Good. So we finish here.